Hello, I'm Yusuf, and today I will be speaking about wind turbine construction process. I want to start with the introduction first. And when we look at the wind turbines, they're really large and really complex to build, so it needs high level of engineering. And you can build them on land or offshore places, but there is a problem with that because you usually get a lot of effect from environmental conditions because when you build them on land, you're usually going to put them on higher places like mountains, and there's going to be a lot of strong winds. And if you put them into offshore places, then there's a lot of wave loads and limited accessibilities. So it's really hard to build them. So when you're constructing them, you need to be really careful with planning, and you need to know some advanced engineering knowledge and precise execution. And in this presentation, I will explain the wind turbine construction process step by step, and I will try to focus on the civil engineering part. So, about the history and development, if you look at the image, you are going to see the first wind farm from wind turbines, of course. And the name of this is Windaby, and it's in Denmark. So about that, in our days, you can build wind turbines really high and you can put them on land or offshore places. But back then, it wasn't like that. So I can say the development of wind turbine technology has accelerated rapidly over the last few decades. So I want to continue with site selection and feasibility. We are doing a lot of analysis to be able to put our wind turbine in a correct place. So we are analyzing wind speed and direction and some geotechnical soil investigations, environmental impacts, transportation and site accessibilities. So they are really important about where do you want to put your wind turbine. So when we continue to onshore foundations, what we are going to see is really important because onshore wind turbines are typically supported by large reinforced concrete. And one common type is that shallow mat foundation, which consists of massive concrete slab that distributes the load to the wide area. So this solution is reliable, but it requires extensive excavation and large volumes of concrete. But we have alternative solutions for that, such as ripped beam foundation or racked anchored system. So you can use materials more efficiently, but require more complex design and construction techniques. But in weak soil conditions, soil improvement methods such as deep ground reinforcement may also be applied to the offshore foundations. So of course there is structural challenges, and the primary one is the moment of resisting to overturning. So wind forces acting on the rotor and tower, and these forces create large bending moments at the base of the structure. And in addition to the static loads, there are some dynamic and cyclic loading issues also. So civil engineers must carefully design foundations to ensure adequate stability and prevent some excessive settlements and limit long-term structural fatigue. So when we look at the offshore wind turbines, they're constructing using either floating or fixed foundation systems. So floating turbines are mounted on some platforms, and these platforms anchor to the base of the sea really good with some strong cables. And these systems are particularly suitable for deep water locations. So there is also fixed offshore turbines, and they're commonly used as monopile, as you can see from the right of the image, and they consist of large steel piles, and they are driven them deep into the seabed so they can provide lateral and vertical stability. And which one we are going to choose depends on the water depth and seabed conditions and some environmental considerations. So of course there is some offshore construction challenges too, and they are really unique because there is heavy installation equipments and specialized vessels, and you need some precise timing to build them safely. And also, when you're building monopiles, you are disturbing the marine life because you are making a lot of noise. So, to be able to block that noise, engineers should calculate some noise mitigation measures. So, about tower construction, wind turbine towers are manufactured in large and cylindrical steel sections, and they are built in factories. So there are some sections, and they transport them to the place where they want to build the wind turbine, and they get them together in that place. So nacelle installation is really important because it is the center of the wind turbine. It is basically the belly of the motor, and it is mounted on top of the tower using a yaw system, as we can see on the picture. And this allows this nacelle to rotate and face the wind correctly, and it's really important for the wind turbine. So modern wind turbines typically use three-blade configuration, and this design offers an optimal balance between efficiency and structural stability, and also cost, of course. And installing blades is highly complex operation because they're really long and they're really heavy, and there is a wind which is loading to the blades. So we need advanced lifting systems and some vibration control methods to minimize the movements of the blades, and it needs precise calculation also. So about modern technologies, we have different systems such as tower-mounted and climbing frames, but we also have digital modeling and simulations. And that is what is really important because we can put all of our calculations into the app that we are using, and the app will do the work for us. I mean, if it is going to stand or not. I mean, if it is available for this environment or not, and we can see our model in the environment before we build it. So it's really good for the safety and of course for the cost because we are seeing if something is wrong or not before we build it. So it's really important. So I want to continue with the conclusion. When we look at the wind turbines, we can be sure that this needs multidisciplinary work. For example, we need civil engineers, mechanical engineers, also electrical engineers to be able to build a good system. And from a civil engineering perspective, we need to be careful about foundation design, load transfer, and structural stability. And we need proper planning of construction to be able to ensure that performance will be good and to be able to sure that the turbine will stay safe. Thank you for listening to me. You can see all the references and resources that I use in this presentation.